Hey there and welcome into Weather Classroom. I'm Meteorologist Thomas Patrick. Hopefully you're having a happy Thursday at this point. And as we head into December, we're talking a bit of some winter meteorology, but also some Western US meteorology. And this one is actually quite applicable for this upcoming weekend, as our topic today is on atmospheric rivers, or the Pineapple Express might be a term you could be familiar with in the area. So this is distinctly a Western US meteorological feature. It can give us some big time rain, and for the mountains, some big time snow, but it can also be really helpful and really beneficial, but an extreme amount of it could be really dangerous as well. And it's something that is going to set up this weekend for the Pacific Northwest, so why not cover it in today's topic in Weather Classroom? Of course, if you love this kind of educational content and you come here often, do make sure that you're hitting like on this video as well as on my page as well. You'll get notifications when I do go live, whether it is for Weather Classroom or any kind of inclement weather that we have across the region, because I do Facebook Lives for any kind of nasty or severe weather event. So please make sure you're hitting the like or, of course, the love button here on this video. But without further ado, let's jump into our topic today on atmospheric rivers. I'm going to show you an example. This is from a couple of years ago, and it's pretty distinct when you see it on the weather satellite imagery of just this flow of, in this case, just cloud cover, but it very much is what it's called. It's an atmospheric river. It's a river of moisture in the atmosphere that is just packed and condensed and almost has kind of clear-cut edges to it as well. If you just follow the cloud cover from the tropics kind of near Hawaii as that stream of moisture just plumes all the way into the Western US. In this case, it's aimed towards Washington and British Columbia, but any kind of variation of this kind of atmospheric river can also hit Oregon, it can hit California, it can hit other parts of the world as well via other ocean basins. But this obviously is one that's going to be quite common because while the waters of the Pacific Ocean near the west coast of the US are usually quite cold by comparison to some other parts, especially the eastern US, this plume of tropical moisture can provide a lot and an intense amount of just moisture in the atmosphere for one, but that usually ends up relating into the rain and snow events that we see more often in the winter time, in this time of year, but it can happen year round if the conditions are right. And I want to show you the computer model for this upcoming weekend. In fact, the time frame that you see here on our computer modeling is about 5 a.m. on Sunday morning. And kind of like that satellite imagery that I just showed you, this one, our computer model kind of plots the same thing. You see this band of rainfall that sets up in the tropics and extends quite clearly but narrowly all the way into the Pacific Northwest. This is an atmospheric river that is going to be setting up, and it's driven by the jet streams. In this case, I have the upper level jet stream plotted on this map, but it's not just the upper level jet that works at about 9 miles above the surface. It's also the low level jet that's always offset. They're not on top of each other, but the low level jet that's about 1 mile above the surface of the earth, and that wind energy helps to drive that column of air and that column of moisture that's getting picked up by the ocean. It's actually the low level jet that will contain the moisture and kind of hold that area and pick up more moisture from the ocean as it traverses along the Pacific Ocean all the way into the Pacific Northwest, at which point it pretty much says, here you go, and it just dumps all that rain and snowfall for our region. So that's the upper level jet stream and the computer model. I'll show you the low level jet stream. This is one that I don't often use on air, but is a great tool to use, and it plots it quite well. You see that stream of that low level jet stream that starts, it has a starting point in the Pacific Ocean, and then it's just that narrow band straight like an arrow all the way into the Pacific Northwest. In fact, you might be able to tell the difference that the low level jet stream, those green shaded areas which represent the higher winds, aimed more towards like Portland and Oregon, but the upper level jet stream, as I let the map play out, is actually offset. It's more towards British Columbia. So it's that angling that actually gives it its strength, because if the jet streams were one on top of the other, it would actually collapse on itself. So it's that angle that helps give it its momentum and stability in the atmosphere. It's just a little quirk of how some meteorological things work. And so that's what's happening kind of in the ocean. That helps to set up the atmospheric river. And then what happens when it comes on land And this is a brilliant illustration from the National Weather Service and NOAA in general, showing that in this case, it's using California as an example because the mountain ranges and the topography play a huge role into why we get so much rain and snowfall, especially in the western U.S. The Sierra Nevadas and the Cascades, very tall mountain peaks and mountain ranges. Oh, when that atmospheric river basically comes into contact with that, remember the low-level jet stream, only at about like 1 mile or 1.5 kilometers above the surface of the Earth, is basically just going to hit the mountains and has to buckle upwards. And it's that upward lifting motion that squeezes out all that moisture. So this is where we get some very significant rainfall across the west coasts of California, Oregon, Washington, and British Columbia. But the mountain ranges, especially in the wintertime, they'll pick up all snow from these kind of events. And we're talking big time snowfall amounts, easily measured in feet. I believe some of the biggest atmospheric river events that I've seen, even just the last couple of years, have dropped 4, 5, 6, or even 7 feet of snow in some of these mountain ranges, especially the Sierra Nevadas. So this is what's setting up for this weekend. It's definitely not the most powerful atmospheric river, and that actually brings me to my last point of this topic, is that recently there's been this experimental atmospheric river category system. Think like hurricanes. We've got Cat 1, Cat 2, Cat 3, Cat 4, and Cat 5, and we can measure the strength and intensity of hurricanes based on their category, which goes back to the wind. In this case, we're actually using 2 factors to determine what category the atmospheric river's strength is. And on the bottom, the x-axis, that's the duration. So 1 day, 2 days, 3 days. The longer duration of event it is, the more severe it's going to be. But also the strength of the river itself. And that's where we get some intense mathematics here. You have maximum IVT, which is integrated water vapor transport. Yeah, I know we're getting a bit into the scientific side, but basically the strength and the speed of that atmospheric river coupled with the duration of the event leads to these categories. But unlike hurricanes, where even a category 1 hurricane can be quite devastating for a number of reasons, in terms of atmospheric rivers, the lower category atmospheric rivers actually end up being more beneficial and more healthy in terms of the event that they are than not, because we live in the west coast of the U.S. We get droughts. These mountain ranges sometimes are low on snowpack, especially back in 2015 in California when the whole state was in this exceptional drought. They wanted an atmospheric river to help replenish a lot of that lost water content for the region. So this can be really beneficial, especially category 1s and category 2s. You get that steady rainfall and the ground soaks it up, the mountains get their snowfall, you get that replenished snowpack, and everyone's generally happy. Even the ski resorts are like, we got our snowpack back, we can go skiing. But on the high end of this, then we can start talking about, okay, what kind of dangers does this possess? Are there flood potentials, avalanche potentials? Is there going to be too much snowfall? Rock slides and debris flows can be a result of very intense atmospheric rivers. So we tend to say that those higher categories, the Cat 4s and Cat 5s, can be quite dangerous, especially if you're living in some of those mountain ranges like Lake Tahoe area. You're getting 4 feet of snow. That's an intense amount of snow and can be quite dangerous. So we do have a scale to rate this on, and it's a really cool tool. If I had to guess what this upcoming event is going to be for the inland Northwest, probably on the weaker end. It doesn't seem like there's any kind of flooding concerns, and the mountains are going to get a replenished snowpack, and it's only going to last for about 24 hours, so a lower duration event as well. But it's really interesting that this is an evolving part of meteorology, and if we start using the categories more often, I think more people are going to be more apt to knowing or even asking, hey, what's the strength of our atmospheric river? Just like we ask, hey, what's the strength of the upcoming hurricane that's going to be hitting the East Coast or whatnot? So I think this is a great tool that we'll be using in the near future here. So to recap on atmospheric rivers, because this is a West Coast meteorology, but also winter weather meteorology kind of event, and we'll see one this upcoming weekend for the Pacific Northwest. An atmospheric river essentially is just a tropical moisture transport system. We often get moisture from the Hawaii area, the Pacific Ocean tropics, and it gets pushed into an area that's usually much colder, like in Washington state. The low-level jet stream, it's that lower wind profile that helps to drive the river itself, and it's quite visible on our satellite imagery with the cloud cover and the rainfall that comes out of this. And the categories, which are kind of a new thing being used in terms of describing atmospheric rivers, can be used to describe how beneficial or extreme or dangerous these atmospheric rivers can be. And I'll actually loop back around to show, again, the example that's going to be happening for this weekend. Here's the computer model for this upcoming Sunday. We have the clear-cut atmospheric river taking the tropical moisture from this region north of Hawaii and streaming it into this river with the low-level jet stream, depositing all that rain in Washington and Oregon, and you can even see the mountain snow getting picked up by the computer model over the Cascade and parts of the northern Rockies. So atmospheric rivers might be a term I'll have to use more often on air. Awesome stuff for this weather classroom. But that'll be it for this week. I'm off next week because, of course, it's Christmas week, so no weather classroom then. But look for one more before the end of the year, as I'll be doing the top 3 weather events in the Spokane area, the inland Northwest as a whole, doing my research, looking back on some of the biggest weather events from 2020 in our area. And I actually want to put a call out to you that if you think you remember a significant weather event for our region, do make sure to let me know in the comments below, because picking out 3, I think the hazardous air quality is going to be up there, probably number 1. But if you can think of anything else significant that happened, we'd love to hear from you and get our viewer inputs on that as well. So that's going to be coming up in 2 weeks' time, and then it'll be a whole new year of Weather Classroom, almost 1 full year of Weather Classroom here on Facebook, YouTube, as well as Creme TV. So thanks again for tuning in today. That'll be it for me. Take care for this upcoming weekend. Going to be a wet one, as we learned about for today. But with that being said, again, look for the next Weather Classroom. Do make sure to hit the like button on my Facebook page. You'll get notifications when I go live with these Weather Classroom segments or any other kind of nasty or severe weather that might be heading our way for the Spokane area. So take care, everybody. That'll do it for today's Weather Classroom. Have a great Thursday. Have a great weekend. Have a great holiday if I don't see you between now and then. Thanks, everybody, and we'll see you next time.